The second part of this section, this is still 6-5? Yeah. The second part of this section is going to get us involved with the synthetic division part of this. What synthetic division is going to allow us to be able to do with polynomials is that we're going to be able to take a binomial, bless you, that has a degree of 1, use its 0 to divide larger degree polynomials. In essence, what you are wind up doing then is you actually wind up factoring via synthetic division. The only thing that's important is that you always use the 0 of the terms, okay? Remember we've been talking all throughout polynomials about what's the difference between the term, what's in parentheses, versus the 0. If in this example here, my term is x minus 2, what would be its 0? 2. So my 0 would be 2. But if my term is x plus 3, what's my 0? Negative 3. Okay? So what you wind up doing here is that you're always, always, always dividing by the 0 of whatever they're giving you. Okay? They give you a term, you divide by its 0. Sometimes they're going to give you the 0 right off the bat, which means you don't have to do anything. So what I want to do is use synthetic division and divide x cubed plus 2x squared minus 6x minus 9, both by x minus 2 and x plus 3, and show you guys where this is headed. So remember how we set up synthetic substitution like a week ago? We just plucked all the coefficients out, put it in the descending order, put placeholders in if we needed it. Same thing. Synthetic substitution is the same thing as synthetic division. We just call it differently. So we have a 1, 2, negative 6, negative 9, and we'll do the first one by 2.
So we just bring it. Okay.
Great conversation. What's my first step? You guys remember on this?
Drop down the 1.
Drop down the 1, then what?
Multiply by 2.
Then what?
Add 2 sub 4. 2.
Yes-ish. All right. Remember we had... What? I said yes.
So you're a teenage member.
What? Yes, because I also resemble a teenage white girl. Okay, I'm glad I just made your guys' day. Anywho, yeah, remember your I just don't get your... So, at this point, did everybody get negative 5 at the end?
Yeah.
Okay. So,
Wait, how is that dividing?
what's happening here?
Because we're taking the opposite.
What's happening here is that you're taking your synthetic division and you're actually doing the shortcut version of x minus 2 into, what's it, x cubed plus 2x squared minus 6x minus 9. You're doing the shortcut version of doing that because as you drop these things through, turning this into an x cubed, you'd have to multiply it by x squared. You bring it around, you get x cubed minus 2x squared. Subtract it, you get 4x squared minus the 6x. Multiply it by, did I forget something here? 4, wait, I missed something here, didn't I? X cubed, 2x squared minus 6x. No, I'm right. 4x, duh, hi. You guys have me all confuzzled. no idea what you're talking about. Anyway, so as you go through, you're getting these same values.
What?
Notice how these are the coefficients here.
Oh!
So when you find the x squared, the other is
You're using coefficients.
So if you were to write that the x squared was
No, because what is, hey, hold on, Emma's got it. As you bring this around, we wound up with, multiplied through, we had 2x, what was it, minus 4, so that you same change opposite, you wind up with a negative 5 as your remainder. Negative 5 here is your remainder. Synthetic division is long division shortcut. How am I getting the what?
So we have to do both of those things, right?
If it says long division works better when you have stuff like this. When you're dividing out by weird value, higher degree division terms. Synthetic division is great when you have single terms.
All right.
That's when you use it. Okay. So what happens here is synthetic division allows you, like Emma was saying, it's showing you your coefficients of what happens. What is it? The quotient? Is that what it, when you divide something out?
Yeah. We're doing it
Quotient.
we stop there when you want us to write that.
We're heading there. We're getting there right now. Because what this is telling me is that my answer would have been x squared plus 4x plus 2 minus 5 over x minus 2. Because the negative 5 is my remainder, my term was x minus 2. Yes, ma'am?
How do you know that, like, the 1 is x squared,
It-
4 is x?
It always goes down 1 degree before you start. And then it goes into,
So wait, it would just be like,
Because-
2 is the 1, and then like,
when you parlay it back to the long division, remember how you started the x out here, you wanted to turn it into an x cubed? Well, you have multiplied by an x squared. It goes into a descending order after that. And this is your descending order with 1 less degree each time. It works every time. Okay.
so that is it every time, like, the 2 will be like the positive number? Like, it's, like, do you get?
It'll be this, it's always going to be the 0. You're always dividing by the 0 of some term. Okay? Let me show the other one here. Yeah, Nessie.
What about the third?
I'm getting there now. I'm going to do that next example. The other part of the problem we just haven't done yet. We put it on another sheet here. So that was part A. Part B was to divide it by x plus 3. If I'm going to divide by x plus 3, what's the 0? Negative 3. So I'm going to divide this one by the x plus 3, so I put a negative 3 out here. I pull the coefficients out, 1, 2, negative 6, and negative 9. I do my synthetic division again. First step is to drop the 1, multiply out, add,
0.
multiply out, add, multiply out, and add. So is there a remainder now? No. In this case, there is no remainder. So if I took that large function and I divided it by x plus 3, my answer would be x squared minus x minus 3.
Do we have to combine those then? Like that one and x minus 2?
No. It's just 2 parts of the problem. That's all. It's just 2 parts. So what this is showing you is that what could you factor out of that? An x plus 3. Synthetic division is a means for factoring. If you get a 0 at the end, that meant that that was a term. What your answer is what the factored form is. Yes, ma'am?
So when we,
Oh.
the A and B, those are 2 different columns.
Yes.
Oh, that makes sense.
Okay. Let me show you another one. If I synthetically divide, let's do these one at a time. If I want to use synthetic division with this one, I have x cubed minus 8x plus 3, and I'm going to divide it by x plus 3. What is my 0 of x plus 3? Negative 3. So negative 3 is on the outside, What goes on the inside then?
1, 0, -8.
Good. And then a 3. And why do we have to put up 0 there? Placeholder, yeah. Yes, ma'am.
What happens if like x plus 3 is like x squared?
You don't use synthetic. Okay. Drop the 1. We got a 0, right?
That means x plus 3 is a factor.
That means that x plus 3 is a factor of x cubed minus 8x plus 3. What happens then is that the answer here is x squared minus 3x plus 1. If I multiplied that by x plus 3, what would I get?
X.
I'd get that.
Minus 8x plus 3.
Notice how this was a problem before that we could not factor? We have no idea how to factor that? Look what we can do now.
The cube rules, that's pretty rad.
What that allows you, what this is allowing us to be able to do is factor the unfactorable. If I had changed it. Sir,
But like, how did you get the left
Ha,
part
ha,
on the bottom?
Yeah, funny.
the left part on the bottom here?
Yeah.
See how we started with the x cubed, x squared, x, and constant?
Okay.
This answer always goes down by 1 degree. So this, if this was cubed, this is going to be squared, x, constant, remainder. If this was to the 5th, this would be 4, 3, 2, 1, so on. Okay.
Well, like the.
Yeah, this is, see how this is the coefficient? 1 minus 3x plus 1. Those are just plucking the coefficients, just go backwards out of that. All right? Yes, ma'am.
Is the answer 0 or the x squared?
This here, the answer is not 0. What it's showing us is that if I divided the function by x plus 3, I would have no remainder. Having no remainder means that it was a factor of the function to start with. That's what it implies. Okay? Let's go back to the other one here. The other one we have x to the 4th minus 16x squared plus x plus 4. It's just a little piece. Is it really going to bother you?
Oh, yeah, was it the mark on it? That's worse though.
Yes.
Okay, thank you.
I hate to bother your OCD. I actually do, but you know, today's Tuesday, so I'm not that mean on Tuesdays. What's my 0? I'm divided by here. -4, good. -4 goes on the out. On the inside, what do I do? 1, 0,
-16, 1, 4.
okay. Drop the 1, -4. Is x plus 4 a factor of this?
Yes.
It is. Now, what am I left with? What am I left with now? What's my answer here?
X cubed minus 4x squared plus 1 times x plus 4. Oh, so you have to put the times x plus 4.
What I'm looking at right now is all we're doing is using synthetic division to tell whether or not it's a factor. If it's a factor, you get 0 for your last values. If that's the case, this answer here is a factored form of it. Yes, ma'am.
If there's a remainder, you just write it like the remainder over there.
Just like we did yesterday in long
Wait,
range.
so we have.
What Emma's question was, if there's a remainder, what happens is that you wind up with a little fraction part here at the end. And I'll show you what that will look like when we go through it, okay?
Wait, so we have to write it, when we write the answer, we have to write it.
Read instructions. As it goes through each one, everyone, I'm showing you possibilities, okay?
I just like this.
All right. Now, want to show you a little bit of how they use a little bit of different nomenclature here. Here's where it gets to be kind of like mixing all of it together. We're going to flat out factor the problem given a bit of information. The information here is telling you that -3 is a 0. It's a factor of it. It's a 0. If -3 is the 0, what's the term?
X plus 3.
Good. You're going to hear me relay those two things back and forth all the time, because as we get further involved into polynomial functions and polynomial factoring, the importance of knowing the difference between the 0 versus the term is kind of important. So if f of -3 equals 0 is a 0, that means the term is what? X plus 3. What I'm trying to show you guys is working the opposite direction. Okay? Eventually, we will build functions knowing the zeros. Okay? We will eventually build functions knowing zeros. It's a very easy process, but if you understand what you're looking at, it makes it even easier. So if I know that -3 is my 0, I'm going to factor out the rest of the stuff. I put the -3 out front, just like we would always, because the 0 always goes on the out. Excuse me. Use my coefficients, 2, 11, 18, and 9. Remember, a very easy way to check yourself if you have enough coefficients is that if you have a third-degree polynomial, you should have 4 terms. You will always have +1 terms to your degree when you synthetically divide. That's kind of the generic reminder rule. Okay? Go through your synthetic. Drop the 2, there's 6, 5, -15, 3, -9, and 0. That tells me we knew it was a 0, so we should get 0. That means I can factor this 2x to the third into, well, x plus 3, because that was my 0. That's my term. And then 2x squared plus 5x plus 3. But wait, there's more.
No.
But wait.
Oh, wait, there's more. Well, if you order it now.
It slices, it dices, it julienne's fries. Anyway, you have to factor this. You have to check to see if you can factor that.
Can't.
What's 2 times 6? Or 2 times 3?
6.
What times 1 is 6 that you add together to get 5?
3 and 2.
3 and 2. So you can continue to factor this.
You have to.
Yes, because it says factor. You have to factor until you can't factor no more.
Oh, wait,
Why?
there's more.
This is what it says to do. What I'm doing here is that grouping method again. I'm splitting out that middle term. Bless you. We did 2 times 3 to get 6. What times what's 6 to add together to get that 5? We got 3 and 2. So if I group them, you'll see this isn't a very difficult problem to group with. GCF here, we get x.
Numbers would be so much nicer if you put the 2's together and the 3's together.
It doesn't matter, still works. So your term then, x plus 3, 2x plus 3, and x plus 1.
Wow.
That is the factored form of 2x cubed, 11x squared, 18x, and 9. Because if you think back to what we did before, when you had 4 terms, you guys would try to factor that by grouping. This wouldn't work, would it? There was no way of knowing if that would work. We couldn't do any grouping there. That's why they developed other methods. You factor by knowing, if you know one of the zeros, you can factor it out the rest of the way. Factoring via zeros is one of the easiest things that we can do. Okay?
So then that's the answer.
That's a fully factored form, yeah. Yeah, you always keep
All they
going.
ever ask is
Yes. Eventually it'll say, and then the next progression would this be, what are all of your zeros? Well, -3, -1, and then -3 over 2. Okay. So you will get to that point. Yes, ma'am? Then I don't want to talk to you. All right. Here, Emma, this is what you were just saying. You only have to solve for the other ones. This question is giving you one of the zeros. Find all the other zeros. Which means you're going to factor it all the way down and find all the rest of the zeros. So in this one we have x cubed minus 2x squared minus 9x plus 18. And we know one of the zeros is 2. And that's what that says. I tried to blow this up as best I could. One of the zeros is x equals 2. So it says 2 is the 0. That's what that means. So if I know that 2 is a 0, what's its term?
X minus 2.
Good. So if you know 2 is a 0, we know the term is x minus 2. I'm just going to write that down so that way I don't forget that later.
There's only 2 zeros.
Well, this one you can, but see how fast it is with synthetic though sometimes? I know you can. Fine. So if my first term is x minus 2, now this becomes x squared minus 9. You agree? And you can factor that real quick, can't you? Oh, fancy schmancy, isn't it? What are your 3 zeros then?
3, negative 3, and 2.
Very good.
Let's go.
Well, you will have it. There's no We'll get there.
I'm gonna make something.
Emma's already worried about the worst case scenario. Is there going to be imaginary stuff eventually?
No, I honestly don't remember how to do that.
We'll help you. What we're doing here today is we're looking at real zeros. We're looking at the real zeros. Yes, ma'am?
Are there any other imaginary numbers?
No, that is the imaginary number.
Oh. Okay.
Okay. All right. Try, let's see which one you want to do. Let's do the, the 0 is 10. 10 is a 0. Okay? 10 is a 0. I want you to find all the other zeros. 10 is the 0. So if 10 is the 0, what's the term?
X minus 10.
0. Oh.
Find all the other zeros on this one, please, using synthetic. Let's see where we're at here. Since you know that it's a 0, you should get a 0 at the end. If you don't, that means you added wrong. Okay. So we dropped the 2, 20, 6, 60, 4, 40, 0. God, I love synthetic division. It's so easy.
I thought that said 4, but it actually said 40. That's why I got that.
So we know that our term is x minus 10, and then I have 2x squared plus 6x plus 4. And remember, I'm trying to find all possible zeros. In that trinomial, what's the first rule of factoring?
You multiply the last
Take out
take out the
GCF. What can I take out of that?
2.
2. You don't have to take out the
When it's small numbers, it's just an extra step.
1 times what's 2? You had the other to get 3.
2 is 1.
Does this 2 have any bearance upon the problem now?
No.
Why is that?
You divide it out.
This is equal to 0. Very good. So the 2 doesn't matter anymore. Not to say that 2 isn't important. It just doesn't matter in this problem. So our 3 zeros in this case are 10, negative 1, negative 2. This is nice, isn't it?
Yeah.
Not really. It really doesn't get that much more difficult, except for the fact that you'll have you'll have to start worrying about imaginaries at some point. Wait. Were you okay about factoring that too? Yeah. Anytime, when you get to this part here, guys, when you get to this part here after you found one of your zeros, you have that term listed, write out what your solution was there, and then just start working with, it's usually a trinomial at that point. Start working with that with all the different ways of factoring. Okay? And go from there. So like I said, we have a 10. That's not what I wanted to do. Let me change those. Do you have it? Okay. Let me give you some of these to try. It's not these, it's this page, but it's not these problems though. We did, because you guys did most of that last night with the long division.
It doesn't mean that we're not having homework, it means he's changing what the questions are.
Yep, that's all. Not having homework.
Don't worry.
No,
That's
oh, it's
just
gross. No, we
silly.
must not have homework. I know, but that's what we're. All I'm doing for this is give me more
Now, I want you guys to see that when you get into the tail ends here, you can get funky answers for some of your zeros. Like there might be an imaginary one you have to play around with. You might have to work with the square root. All right? Try those out. You shouldn't have too much of an issue. The first group is just about, they give you a zero, just factor it. The other ones are, given a zero, find all the other zeros. Okay? Yes, ma'am.
So like, let's say for instance, synthetic substitution, I'm like a fraction.